In today's lesson, we are going to learn about the electric cycle. As many of you already know, there are many analogies between water and electricity. We have learned that water pressure is analogous to voltage. We also consider that water flow in a pipe is analogous to current flow in a wire. Today we are going to learn the relationships between the electric cycle and the hydrologic cycle. First, let us review the hydrologic cycle. Moisture evaporates from water surfaces, such as lakes or streams, and rises into the atmosphere where it forms clouds. These clouds are carried over the Earth's surface by westerly winds, and as they rise over the mountains, the clouds are cooled and the water vapor condenses to form rain or snow. This rain flows into the river or streams and then back into the ocean or lakes, where it again evaporates, thus completing the hydrologic cycle. In the electric cycle, the electrons are also in the ocean. These electrons, while in the ocean, have an opposite charge from the clouds and jump to the clouds in spectacular lightning bolts. The electrons travel with the clouds until they are over the mountains. The electrons in the clouds are opposite in charge from the mountains or Earth, so the electrons jump back to the Earth in awesome lightning strikes. Then the electrons are carried by the water out of the mountains and hills and into the streams. In our first lesson, we learned from Benjamin Franklin that lightning was made up of the same kinds of electrons found in carpets. When we brush the carpet, we pick up electrons. Brilliant scientists such as General Electric and George Westinghouse discovered they could put a wheel in the streams and brush the electrons off as the water passed by. Thus, the first hydroelectric plants were built to provide electricity to factories and homes. It soon became apparent that the streams did not have enough electrons to serve our needs. Presidents Teddy Roosevelt and Franklin Roosevelt solved this problem by authorizing the building of huge dams to store the electricity until it was needed. This also helped increase the electrical production as the electrons became more excited as the water in the penstocks rushed under tremendous pressure toward the wheels and brushes located below the dams. From the hydroelectric plants, the electricity is carried by power lines to the homes and factories, where it is used and then grounded. In other words, connected to the ground. Once into the ground, the electrons again attach themselves to the water, where below the dams they return to the streams in springs and complete the electric cycle by returning to the ocean. There, the electric cycle is repeated again and again. In later years, tests of the water returning to the ocean revealed that a lot of electrons had been lost. Electrical and mining engineers discovered that the electrons had stayed in the ground, attached to coal and uranium deep down in the earth. We now get this lost electricity by burning the coal or heating the uranium so the electrons can get excited and be brushed off in power plants that are not on the river at all. This is an anomaly to the standard electric cycle.